Today's lesson is 9.3, Concentrations of Solutions. Good evening, everyone. As I mentioned last class, we were going to cover two lessons tonight. We are covering 9.3 and 9.4. So these are two relatively short lessons. So they're relatively short lessons, and that kind of focus more on equations as well as some sample problems. Okay, for you to follow along. Okay, so let's start here. 9.3. Today we're going to look at concentrations of solutions, and one of the things to make note of is the way the concentration is worded. There are going to be a couple of ways in which concentration will be worded in a lot of the problems in this subchapter of 9.3. Okay, so let's begin here. Concentration is the amount of solute per quantity of solvent. Okay, so you're always looking at the amount of solute in comparison to the entire to the solvent that you are using. Okay, so here's an example. Phenol is a very volatile chemical. And in high concentrations, phenol can actually be very deadly. In low concentrations, however, phenol is actually a component used in certain medicines, in certain disinfectants and antiseptics. Okay, so you've probably heard in the news recently, if you follow a little bit about American politics, Trump was saying about using disinfectants to try to kill the coronavirus. Well, he was kind of trying to suggest, I guess, as all the jokes about him have been coming out with regards to his comment, was using some kind of disinfectant to spray the virus. And understand that what you're bringing into the body is this phenol, which can be rather deadly. Okay, so let's look at the concentrations. Now, there's another equation that you're going to be introduced today that deals with concentration. That one is based on specific compounds and not looking at the solute per solvent component. Okay, or solute to solution component. Okay, so when we are mixing two things, when we're mixing two things together, we're mixing, let's say, a solute within the entire solution. We could be looking at these so-called percentages of concentrations. And these percentages of concentrations vary between either concentration or percent composition of mass, percent concentration of volume, or what's referred to as a mass volume percent. Okay, so these are the three concentrations that deal with percentages. Okay, you'll notice in questions that it will actually ask you for the percent of the concentration, and not to mistake this equation with what we're going to do at the tail end of 9.3. But let's look at the mass percent. What we are looking at is two masses in grams, but the first mass is of the solute. So we're going to put some solute into the entire solution, right? Whatever the mass of the entire solution. So understand that this solution part will be solute plus solvent. So solute plus solvent will give me the entire solution. Okay, so sometimes you might be asked to add the two masses together, or sometimes you'll be given the entire mass as is. But anyhow, so what you're doing is you're finding the mass of the solute, dividing it by the mass of the entire solution, and multiplying it by 100. You'll see in some things, some household products, tonight when you go brush your teeth, look at your toothpaste, and your toothpaste will actually have a weight percent of fluoride. Okay, so in essence, it's the exact same thing. It's identifying how much fluoride is divided, or the percent of fluoride in that tube of toothpaste in comparison to the entire solution of the toothpaste. Okay, so when you brush your teeth tonight, check that out. Next one here we're looking at is the the percent volume. You're looking at the volume units of your solute and solution. Now, make note of this here. These units can be either liters or both can be in milliliters. But remember, they both must have either liters or they're both milliliters. If one unit is in liters and the other one is in milliliters, convert one of them. Make sure that they're both share the same volume unit, because remember, in essence, really, those units are going to cross out. Okay, those units are going to cross out, but they can only cross out if those two units are exactly the same. And lastly here, a mass volume percent gives the mass of the solute dissolved in some kind of volume. Okay, so understand though, here is a unit that is a must, and let's highlight that here. Okay, the volume of the solution must be in milliliters. Okay, this is the only time when you're using this equation, it is the only time that you are going to keep your volume units as milliliters to do your calculation. Okay, because every other time we're typically going to be using liters. However, be aware that in most sample problems, your units are going to be given in milliliters. In this case, you're not going to need to convert anything. But in these other cases, in this case here, you might need to convert one. In the concentration equation that I'm going to share at the end of this lesson, at the end of 9.3, that one has to be in liters, but we'll talk about that in liter. We'll talk about that when we get there. But anyhow, milliliters is one of the most commonly used units when we're calculating volume. And one of the reasons for that is when you're looking at a graduated cylinder, the graduated cylinder in which you measure your volume is in milliliter units. So that's the reason. It's not for the sake of, okay, well, when you get one of my tests, or you're going to get an assignment next class, that milliliter conversion to liter and then maybe back to milliliters again is only to give you a number that is physically measurable in a lab scenario. Because if you're in a lab scenario, your units are always going to be in milliliters. Okay, so understand that when I give you those numbers, it's not to add an extra step. Oh, there's Mr. P trying to make my test harder by adding one more mathematical step that I need to do any of my calculations. It is strictly because in chemistry, you typically will be measuring in milliliter units. Okay. Let's move on. Another concentration that we're going to be looking at here is concentration in PPM or PPB. So PPM stands for parts per million and PPB parts per billion. Again, one thing to understand for the parts per million, we are using mass units for our solute over solution. Solute over solution. Just like we saw here. Solute over solution. So all these percent concentrations that we're looking at, they all deal with your solute divided by the entire solution of whatever you are mixing. Okay, so in this case here, this mass of the solute divided by the mass of the solution multiplied by 10 to the power of 6 to give us our parts per million. All right, this 10 to the power of 6 is million. Okay, and this 10 to the power of 9 would represent the additional 3 extra zeros in a billion. Okay, so in all the sample problems that you're going to see in all the homework questions, all it is just, throw these numbers into those equations. But we'll look at the solutions to those sample problems in a moment. Okay, this is the last equation for 9.3 before we get to the sample problems. So here is a new equation, a must to remember, particularly because this is the equation that you will be using for any stoichiometry, any stoichiometry or even limiting reactants when dealing with solutions in Unit 3. Okay, so remember that in Unit 2, we looked at the mole, but we looked at the mole as being mass divided by molar mass. But here now, this N is no different to the N value that we might use here. But here in this case, we were looking at the mass and the molar mass. But here, okay, for this equation here, we are really looking at the number of moles, right? Our mole value, concentration, and to give you what the units are for concentration, concentration units are mole per liter. So here is a must. Okay, here is a must to acknowledge. This volume, okay, must always be in liters. Okay, liters. Most of the times in sample problems, they will be given to you in milliliters. So you will be converting for all stoichiometry problems, any milliliter units to liters. Your liters need to be always your volume units when dealing with concentrations in any type of stoichiometry problem. Okay, understand that sometimes we might revisit this equation to help us find this, numbers in this equation. Okay, as you'll see in the sample problems this evening. Okay, understand here now. Let me give you a value here. So here's a value. Let's say 5 moles per liter. That's a C value. That's a concentration. Another way that you will see moles per liter written is as such: 5 capital M. This capital M stands for molarity. Okay, so it stands for molarity, but it represents moles per liter. So understand that you might see these two sets of units interchanged in questions. They're no different. They mean the exact same thing. To be honest, I don't care which way you use to give me your answers. Either one of those units are fine. Okay. Oftentimes I will use this in my question because it's easier to do any crossing out that I might need to do, right? If I need to cross out moles, let's say, or if I need to cross out liters for something, it's easier for me to kind of track, while if I write it as a capital M, that crossing out won't help. Okay. But again, if you're not using units throughout the process, that's not going to matter, as long as you know that at the end, any C value that you're being asked to find, that you will use that capital M, or you'll use the moles per liter. Doesn't really matter. So there are 7 sample problems here at the end. We are going to quickly run through these sample problems here, just to kind of share with you the difference between the equations. Okay, so here is the very first one. Pharmacist adds 2 milliliters of distilled water in 5 grams of powdered drug. The final volume of the solution is 3 milliliters. What is the mass volume What is a percent mass volume of the solution? Here's the other great hint about what do you call it? About these percent concentration equations. Typically, it's going to be given to you as such. So if you look at it, look at this part right here, mass volume. It's already telling me I am going to take the mass and I'm dividing it by a volume. And remember that the top one is always going to be that of your solute, and the bottom is that of your solution. And in this case, because we're looking at mass volume, our volume must be in milliliters. Okay, so we divide the two numbers up, right? Multiply by 100, and we round to the proper number of significant digits. And your final answer is going to be a percent mass volume. You might have it down as mass volume percent. It doesn't really matter the order in which you write the units at the end. Okay, but remember that you're kind of stating that, yeah, I divided my mass, I divided my volume, and I found its percentage in which that solute exists in that entire solution. Okay, let's look at the next sample problem. So in the next sample problem here, it's asking us for our mass volume again. Okay, so we've got mass volume, and if you read the question, it tells us our mass volume percent. It's asking us for how much solute in 2,000 milliliters. But notice that the question gave it to us in liters. This is the only time. Okay, I repeat, this is the only time that units must be in milliliters. Typically, we use liters for volume. Okay. Next question. Now we're looking at mass percent. Right. Again, no different. Take the mass of the solute, mass of the entire solution, and divide. Another problem, not much different to the other one. Again, just kind of just substitute into the equations. Okay, and here's our parts per billion. Okay, our parts per billion, parts per million question. Again, same thing. We're looking at the mass of the solute over the mass of the solution. So really, all this section is just practicing. You're just substituting into equations. That's really all you're doing in 9.3. You're substituting into the equations to find whether you're finding the mass of the solute, mass of solution, volume of solute, volume of the solution, percent, parts per billion, parts per million. I typically don't give too many of these types of questions in tests and quizzes and assignments just because they're not seen as often as you would see the last equation that I shared, that C is equal to N over V. Okay. So practice these sample problems. Here's one that we're going to, take a little time to take up. So if we look at this question here, we've got a saline solution, contains 0.9 grams of sodium chloride dissolved in 100 milliliters of solution. What is the molar concentration? Okay, so we're not looking at a percent mass or percent mass volume or percent volume. It's asking us just for the molar concentration, or it might say just concentration without the molar part. Okay, anyhow, one of the first steps I like to do, I like to list what I'm given. So I'm given a grams, I'm given a mass, and I'm given a volume. And here's this equation. Okay, let's pretend let's ignore this one right now. Okay, let me cross that out. Okay, let's ignore that. Right now, in this equation that I just gave you, I only have this. There is no other number I've given you in this question. Okay, so that's why it's so important to bring back some of the old stuff that we've known, right? And so that is the Unit 2 content. And in Unit 2, this this mass value, that fits in here. Okay, that fits in here. The fact that I have sodium chloride, okay, metal, non-metal, crossing over the charges, and the formula works out to NaCl. Oh, wait a second. I could find the molar mass of anything, any formula that I've been given, which means I have this value, I have that value, I can find my number of moles. So once I find my number of moles using the unit 2 equation, I can now take that N value, put it into this equation with the volume that I'm given from the original question to help me find the final mass, find the actual concentration. Okay, so let's erase some of this stuff here so we can see. So we find the molar mass. Again, always when you are using molar mass, you are using my periodic table. Okay, because when my answer keys, that's how I follow along to make sure you've been rounding correctly and that I know that you're not Google searching your answers. Anyhow, so we take our mass, we divide it by the molar mass to find our number of moles. Please do not round this number. Do not round this number. So we're going to take this now into our new equation that we've just been introduced today. C is equal to N over V. I don't have to write out my number. I don't even have to write that out. I write this out for you guys just so you guys can see what your calculator should be spitting out. But in terms of how you document this when you're answering questions, just let me know with this little ... here. Just let me know that, yeah, I'm carrying over all these numbers and I'm not rounding it. Anyhow, I take the values, I divide it by, notice here, my volume, milliliters, into liters. When we use this equation, okay, this volume here must always be liters. Always, always, always. Okay, only in these ones can they be are they to be used in milliliters. But in these questions, whenever you're using this, always in liters. But be aware that I typically give volume in milliliters. Reason for that, you can measure this using a graduated cylinder. Graduated cylinders aren't labeled as such. Okay, so imagine trying to measure out 0.1 of a liter. So take 2 of those water bottles. If you drink one of those 500 milliliter water bottles, 2 of those will make 1 liter worth of water. So 0.1, imagine, having, where these points are going to be if they were going to be measuring as liter. It's going to be very difficult to acknowledge, but to measure out 100 milliliters, because graduated cylinders are measured in, or the units that they're labeled in are in milliliters. So our answer works out to 0.15 moles per liter. I'm not giving you 2 different answers. It's the exact same thing. It's just I'm using this molarity unit for my concentration. And be aware, notice where this M is. This is followed by the number, as opposed to this M here that represents molar mass. Okay, remember, it's follow the number here. Here it's before the number. So they're not the same. Okay, for those who get confused. Second one works the exact same way as we did in the sample problem 6. Okay, this time we're given our V and we're given our C value. But the question asks, what mass? So right now we're given this information. So we've got our V here. This V fits in here. This C value fits in here. So we're trying to find our N value. Once we find our N value here, right, here's our N value, we then substitute it into this equation here with our molar mass, provided that you know how to put together the formula for calcium sulfate. So there is the molar mass of calcium sulfate. Be aware that they crossed over both oxidation numbers of +2, -2, and that's why this formula works out that way, exactly to the way it's written out. Okay, so be aware of how to put together formulas. Okay, because that was one of the struggles that some of you did when calculating your molar masses. You struggled putting together your formulas. So make sure that you note that. Okay. I hope you liked this video. If you did, do not be shy to hit that thumbs up button. And while you're clicking the thumbs up, click on that subscribe to stay tuned to my new videos. Thanks for watching.